Looking at question 6 of the prelim paper of November 2022, the prelim paper of 2022. And if we look at the question we are looking at is question 6. A small polystyrene sphere B hangs from a ceiling and is attached by a string of negligible mass. Right. Two spheres A and C are suspended on insulated stands. We've got that. The charges on each sphere A is 5,6 nanocoulombs, B is minus 2,34 nanocoulombs, and C is minus 7,46 nanocoulombs. The mass of sphere B is 5,085 times 10 to the minus 3 kilograms. Okay, and then if you look at the answers, define the electrical field strength at point B. Here you should know your answers according to your definitions that you learned. The electric field strength at a point is the electrostatic force experienced per unit positive charge placed at that point. So it's important to learn your definitions exactly so that you don't lose marks. For example, you won't say unit positive charge. So that's very important that you learn your definitions correctly. Question 2, 6.2. Sketch an electric field pattern across sphere B and sphere C if A is removed. So if A is removed, sphere B has a charge of minus 2,34 nanocoulombs, so it's a negative charge. Sphere C is minus 7,46 nanocoulombs, so it's also negatively charged. So if you have B and C that are negatively charged, then we know that the electric field pattern will be such that they will repel each other, they won't go towards each other, and the electric field lines come towards each of the spheres, and there's a repulsion force. So if we draw it, we'll see that you got B and you got C. We see that the field lines come into the spheres on both sides. We see that the spheres don't touch, and we see that the spheres are directly connected to each pole on both sides. Alright, so that's important. So something that you shouldn't lose marks for. Make sure that the spheres are directly drawn. Learn your theory well. It's 3 marks so far. 5 marks that we should have got into the bag. Right, now when we come to question 6.3, charge B experiences a net force of 0,004078 newtons due to charge A and charge C. So charge B experiences a net force. So when you see force, then the equation of electrostatics that comes into play is F is equals to K Q1 Q2 over R squared. So we must know that that's the equation that is relevant. That it is due to charge A and sphere and charge C. Find the distance between charge B and C. So we got a distance between charge A and B. Excuse me, 6 millimeters. Between B and C there's a charge. We don't know the distance, so we can work that out. So we got F is equal to K Q1 Q2 over R squared. So let's write it down. We see that the net force will be the force of A on B and the force of C on B. So if we write it down, we know that the net force is 0,004078. That is given as a net force between the two spheres. And the first one, F of A, the charge of A on B, F is equal to KQ1 Q2 over R squared, and the charge of C on B, KQ1 Q2 over R squared, the same thing. So if we substitute it, K is equals to 9 times 10 to the 9. Q1 will be the charge of A, which is 5,6 times 10 to the minus 19. The charge of B will be 2,34 times 10 to the minus 9, because it's 2,34 nanocoulombs minus 9, and R squared will be the distance between the two spheres, which you know as 6 millimeters. So we take the 6 millimeters, 6 divided by 1,000, will give us 0,006 squared. So that's the charge of between A and B. Now between C and B, I don't have space on the right hand side. It's better to put it on the same side, but I'll put it below that. So we got K is 9 times 10 to the 9. Q1 is 7.64 times 10 to the minus 9. Q2 will be 2.34 times 10 to the minus 9 over r squared, and we don't know what is the r squared. The distance between the two is unknown. So if we take it further now, we see that we've got numbers on the left hand side, the f net. We've got all the numbers for f on A on B, and on f on B, C on B we don't know r squared, and that is what we want to find. So if we take this top part and we calculate it, 9 times 10 to the 9 multiplied by 5,6 times 10 to the minus 9 multiplied by 2,34 times 10 to the minus 9 divided by 0,006 squared, we see we get 0,003276. So this is using the calculator. Alright, and then we know that the charge of the net force is 0,004078. So to work out the second part, 9 times 10 to the 9 times 7,46 times 10 to the minus 9 times 2,34 times 10 to the minus 9, and that must be divided by r squared. We see we get 1,571 times 10 to the minus 7 divided by r squared. So this is what we have on the next step. Now to work out r squared, what we can do is we can take the 0,003276 and put it onto the other side, and we're left with 1,571 times 10 to the minus 7 over r squared. And if we do that, we see we get 0,000802 is equals to 1,571 times 10 to the minus 7 over r squared. Now when we have this here, we can calculate r squared. We take r squared, we put it onto the left hand side, and we put this amount below the 1,571 times 10 to the minus 7. And if you work that out, we see that r squared gives us 1,96 times 10 to the minus 4. But that is r squared. So if you want to work out r, you find the square root of 1,96 times 10 to the minus 4, and we see that we get an answer of 0,01399619590,245. So if you take that amount, we can write it down as 0,013996 meters. Correct. So that's what we can do, or we can, if we have to round it off, if they'll allow us, we'll say 0,014 meters. That is what we will do to put this down, right? I'll just put it in brackets here so that we've got it. 0,014 meters. Don't forget to write your units. Very important. All right. Then coming back to the question, the next part of the sum says charge A and B are allowed to touch. A and B are allowed to touch. So the moment they touch, what tends to happen? We see that the electrons will move and then move back to the original distance between them. Calculate the new charge on the sphere. So if you have to calculate the new charge on the sphere, we'll say you add a 2 and you divide by 2. So we'll have to go on. So this will be 6.4.1. 6.4.1. The new charge, not the new force, be careful. The new charge, Q, the new charge will be Q1 plus Q2, and we have to divide it by 2. And here, because you are looking at the charges, we have to put in the charge sign as well. So it will be 5,6 times 10 to the minus 9 plus, and then here you see minus 2,34 times 10 to the power minus 9, and then you have to divide that by 2. So if you divide that by 2, if you work it out, we get 1,63 times 10 to the power minus 9 coulombs. So that will be the charge, the new charge that we will have between Q1 and Q2, A and B. So that will be the new charge that we will have. 6.4.2, explain the change, if any, to the field pattern between B and C. So what we know about B was originally minus 2,34 times 10 to the minus 9, and C was minus 7,46 times 10 to the power minus 9. That was originally, but now the charges touch. So when they touch, the new force that we have on each sphere now is 1,63 positive. That will be positive. It will be positive. So it will be positive 1,63 times 10 to the minus 9. So this charge is positive 1,63, and C, you're looking at between the charge between B and C. This is positive 1,63 and this is negative 7,46. So originally they were negative, both were negative, so there was repulsion. But now, because B has become positive, then there will be attraction. So let's write that down. 6.4.1, 6.4.2. B has now become positively charged. Alright, and we can say thus, because C is negative, we will now have an attractive electric field strength. We'll have attraction. Right, so the electric field will be an attractive pattern. The field lines go out of B and into C. Right, so that will be the more or less the answers for 6.4.